So how's weather there?
Maybe it's raining actually, and it's very cloudy. So, like last week only, like it was kind of end of the summer. So yes, winter is coming actually.
It's raining here also today, quite heavily with thunderstorm, which started only a few minutes back.
Yeah,
Yeah.
and they
So
say like
climate change is.
UK, like slowly in November or like December, the sunset will happen at 4:30 p.m. So you have most of the dark during the day.
So here seasons are going back like 1.5 months back.
Yeah,
बारिश शुरू भी लेट होती है, जाती भी लेट है. That is how things are. I think we can start the event.
yeah.
So good evening to everyone here on this call.
Hello.
And hello.
Hello. Chaitali, can you hear me?
Yes, ma'am, I can hear you.
Okay, that's great. So that's really the digital revolution. I'm sitting somewhere in the middle of the jungle, and mm, I welcome you, Akash. It really feels great that our alumni are coming and talking to our students.
Thank you. It's
Hello.
my pleasure.
Yeah, Akash. So somehow it has become possible, and we could begin with you. So I welcome once again on behalf of Department of Architecture, and I won't be able to stay for the full talk, but definitely I would request our students to record this talk, and then I think I'll be able to be part of this. But I'm very sure that our students will be delighted to have you, and there'll be a mutually enriching experience of be part of your experience regarding energy efficiency, regarding climate change, regarding our design decisions in our day-to-day life. So I welcome you once again, and I think over to Chaitali and the students. I think we can begin the talk, and I declare Atelier open for uh, academic year 2021-22. Thank you.
Thank you.
Yeah.
Thank you, Akash, for taking time
Thank
out
you,
on
ma'am.
your holidays and sharing your knowledge with our students. I'll now hand over the event to the students.
Yeah.
Thank you for accepting our invitation.
Have positive and hopeful emotions that encourage you to look forward to a bright future, one in which you believe that things will mostly work out. Keep yourself busy with a feeling of pleasure and contentment in the way things are going, a general sense of enjoyment and enthusiasm for life. Sharing of thoughts, discussing ideas, and preaching theories and values lead to positive outcomes, transforming today's ideas into tomorrow's outcome.
A very good morning to our esteemed guests, fellow students, teachers, and everyone virtually connected here today. On behalf of students of Department of Architecture, the Maharaja Sayajirao University, I, Rahi,
And I, Khushi, welcome you all to the fourth edition of Atelier.
Atelier is a series of lectures which was started by the Department of Architecture in 2019. It is platform of sharing knowledge, transmitting ideas amongst people from different spheres of architecture. This lecture series creates an opportunity to gain knowledge and experience in varied topics out there. Atelier connects the students with professionals of this field and paves a way for open discussions and learning.
Okay, to begin with now, we would like Chaitali ma'am to welcome sir and share a few words with us.
Didn't I not welcome him already? Akash, now I
Okay,
formally
ma'am. So, sir,
invite
uh,
you so he's here with us. He is one of our alumni and working with Foster Plus Partner, as everyone knows. I would request all students to feel free and ask him questions. ज़्यादा मत सोचना कि ऐसा क्वेश्चन पूछेंगे तो कैसा लगेगा, because he's one of us. So I hope Akash you don't mind if students just bump
Yeah,
with
yeah, they're free to ask
any type of
anything,
questions
for sure.
and make this session be more interactive. And after his presentation, Akash, if possible, if you could spare some time interacting with students informally,
Sure, sure.
apart from what you are delivering, it would be great.
Yeah.
Thank you. Over to you.
thank you, ma'am. So, architect Akash Changlani pursued his BA from M.S.C. Vadodara with a master's degree from TU Delft, Netherlands, in building technology. He has expansive knowledge in advanced technologies and gifted insight into various environmental factors in designing. Keeping his focus on sustainable designs, he graduated with majors in computational design, facade design, and building physics, gaining a deeper grasp of integrating climate responsive, energy efficient, carbon neutral, and circular strategies into the design for improved efficiency.
Alongside his studies, he worked for 1 year as computational developer and building performance analyst at OMRT Amsterdam. Currently, he is working as a sustainability designer at Foster+Partners London, where he is involved in several projects of multiple scales across the globe. His expertise includes analyzing, advising, and designing sustainable solutions for teams within Foster+Partners.
On behalf of our department, we welcome you, sir. So, without further ado, I would like to hand over to you for your presentation.
Thank you all. So I'll share my screen now, and I think I'm free to begin now. Right. Can you all see my screen? Hello, can you all see my screen?
Yes, sir.
Not yet, sir.
Not yet. Now?
Yes, sir. Yes, sir. It's there.
Yeah. Okay, all right. So I'll begin it. So yeah. So the topic of today's presentation is sustainability next, as I think all of you know it. And yeah, I did prepare my introduction as well, but I think like everything is covered, but I will just share some of the timelines of my introduction. So I began my Bachelor's of Architecture in MSU in 2010, and I graduated in 2015. Then I joined SAM Architects in Ahmedabad. I was working as project architect, and I worked there for like 3 years. So after working over there, like I understand, like I want to develop my skills more further, and so to expand my knowledge towards advanced technology and various environmental aspects into design, I went to TU Delft in Netherlands to pursue my Masters of Science in Building Technology. So I began my study in 2018 to 2020, but in the middle of it, I also worked with OMRT for 1 year as a computational designer, computational specialist. And yeah, recently after actually completing the journey of a whole decade into architecture, recently in 2021, I got the opportunity to join Foster & Partners as a sustainability designer, and I'm working in their main head office in London. So I will start with the presentation, and let's begin talking about sustainability. So what is sustainability? So actually there are like many versions of definitions that explain sustainability. and among which one of the most commonly used is from our Common Future report that states that sustainability development is defined as development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So basically, the sustainability development is it compromises three different pillars, which is environment, economy, and society. And there should be a good balance that should be achieved between all of this. But this presentation at the moment will only cover the environmental aspect. And based on those three pillars, United Nations in 2015 launched 17 Sustainable Development Goals with the agenda to achieve sustainable development in every sector by 2030. But some of the points that goes with architecture are in highlights. And one of the main point is 11th, which is sustainable cities and communities, which is mostly related to our field. And just after that, in December 2015, 196 parties all across the globe came together and signed Paris Agreement, which was basically to prevent climate change. The Paris Agreement actually is a long-term temperature plan, which is to keep the mean global temperature below 2 degrees Celsius, which was above pre-industrial level. So they are considering pre-industrial level as a 0 degrees Celsius. And right now we are almost at 1.1 degrees Celsius. And if we go in the same pace, if you see from the next graph, the gray line shows the warming projections, like if we don't take any steps and if we consider the same construction techniques in the recent ways that we are currently doing, then it will almost increase the temperature by 5 degrees Celsius, and which really means a lot. And there are like many certifications, policies, and pledges and targets that has been going on right now. Even if we follow those targets and certification, we could still be achieving in between 2.5 to 3.5 degrees Celsius. So how can we achieve a target which can be a 2 degrees Celsius or even less than that, which is 1.5 degrees Celsius, which is the main agenda of Paris Agreement? So not focusing on the final goal, but limiting to the shortest goal, which they have actually launched, which was to attain 40% greenhouse gas reduction by 2030 and 95% greenhouse gas reduction based on current stage reduction by 2050. So there are some certifications that you might be knowing about, like which is LEED, BREEAM, WELL, which are very commonly used nowadays. But even if you graph these targets, they actually don't help to achieve what Paris Agreement was aiming for. So even the highest certification level, which is LEED Platinum, it still helps you to achieve only 3 degrees Celsius, but not towards 2 degree or either 1.5 degree. So how do you bridge that gap? Like how to attain such kind of climate-free construction techniques? So Foster+Partners is one of the first architecture practice which signed this net zero carbon building commitment. And the company has also pledged to make all the buildings used by the practice to be carbon neutral by 2030. So I will be introducing you through some of the approaches that can help to achieve such intensive targets. So let me begin with passive design. So passive design is mostly the first thing that comes into your mind when you have to design some sustainable project. And this strategy takes usually the advantage of the external climate to maintain a comfortable temperature range, which is for the inside of the room. And some of the strategies that you might be aware about are natural ventilations, daylighting, shading, passive cooling, heating, use of renewable energy, and use of natural materials. So you might have, or you will be in your education period, you will come across such strategies even more in detail. But today I'm here a lot for explain you what passive design or to show example of passive design. But I will be taking this step a little bit further. So after having a passive design, after you have decided what passive feature you are giving into your design, but after that, how do you quantify the performance and how do you know that comfort level of the passive system will be achieved? And how do we know that the strategy is working or not? how do we achieve the optimal performance that you are aiming for? So what is the next step to go beyond passive design for sustainability? So this leads to our second topic, which is performance-driven design. This section will show an approach to achieve and quantify the optimal performance regarding several aspects. So one of the approach is computational design method, which includes three main steps. And I will begin saying that like you might be aware about like Grasshopper tool, which makes crazy shapes and forms, but that is of course like really good, but that tool can do much more than that. And that crazy shapes and geometry comes under only this first step, which is parametric geometry. So where you can alter the design based on some parameters, like here, like taking example of this tower, like you can twist the tower, you can change the height of the tower, altering the cross section of the tower. But the second step is performance simulation, where you can perform simulation using simulation plugin within Grasshopper, and which are available for daylighting, energy, radiation, wind, and many more. And the third step is to optimize. So optimization is the process where an optimization tool in Grasshopper plugin will actually help you to alter all of your design with simulation and give you the best and most optimal design to select based on your own criteria. The only thing which is most important in this method is like you should know how to read the result from simulation to know which option is the best. So let me take you through one of the examples that I worked on. This first project is my graduation master thesis called Facade Elite. It was located in Rotterdam, Netherlands. And the main topic was facade optimization for visual comfort by controlled daylight distribution in high-rise office buildings. So Lee Corbusier once said, like, the history of architecture is the history of the struggle for light, and it still remains the truth. So one of the current struggle that is being seen by are in high rises. So high rise poses a struggle because only side walls are the option from which the light can be penetrated in. So in deep floor plans like office building on high rise, it creates some kind of a glare near to window, and the light, it doesn't reach to the end of the depth. So it somehow creates a gradient of intensity of light, which goes dark towards the greater depth, which somehow creates non-uniform distribution of daylight, and it creates visual discomfort to the occupant of that space. And you can see here like how people are reacting to this different light situations. So the ideal solution would be to bring more balanced distribution of light along the whole depth. So how can we achieve that? But here, like, the solution is difficult. We can actually question ourselves why. Because daylight has dynamic nature. The daylight intensity and sun position changes throughout the day and all along the year. So this brings the complexity into design. So how can you achieve this? And usually, like with the conventional design method, it again brings difficulty, like you cannot quantify it, like how we will achieve it. So computational design method is one of the way which allows us to actually solve this kind of an issue, to have a more improved performance and get the most optimal solution. So here my main objective of thesis was to design a facade system that control both aspects, enhancement of daylight for greater depth, and reduce and diffuse daylight from the front, which are overlaid zones, which create glare and create a uniform distribution. And it should be adaptive and responsive to daylight, dynamic daylight. And in the end, finally, it should give some kind of a visual comfort. So based on this literature study, I formulated some of the visual comfort criteria, which was in combination of Preamp 2016 and some Dutch regulation, which could help me to evaluate my facade performance. This includes some of the factors which affect daylight, which are daylit area, average illuminance, uniformity ratio, glare, contrast ratio. So light is just one of the things which you need to know is like for now is like light is usually calculated in lux. So basically light between 300 to 2000 lux is daylit, and it's a useful daylight which is comfortable to human eye. And if it is more than that, it will create glare. And if it is less than 300, it will create some kind of a blindness. So after that, I actually selected some of the diverse external daylight factors from dynamic nature of daylight. And I chose south face with 2 different seasons when sun will be the highest position and the sun will be at the lowest position. 3 different time period of the day having different azimuth from east to south to west, and 2 sky condition where there will be direct sun and no sun with diffuse light. So the final goal is to bring all different condition into daylit range. So I began my design concept by taking an octagonal kaleidoscycle, which is again a dynamic geometry. And I divided into different parts, and I actually selected a pair of tetragonal dysphenoid to my facade. And I actually modified it further, this module further to give it a fold, which can fold like this. You can see in the GIF. And it allowed me to have 8 different kind of variations. And now let me show you what advantages it brings. So first of all, it allows to control the percentage of openness and closeness for penetration of light inside the room. It also allows me to control surface available for redirecting and blocking of the incoming light through different available surfaces. And I can also give different material with different optical properties on different surfaces. So it allows wide range of possibilities to control percentage of openness when configured as facade. And one of the modification I added was to have top 2 rows rotate inside to reflect light to the greater depth, and bottom panels rotate outside to diffuse light in front of the room. So after developing concept, it was time to apply computational design method where the geometry will be converted into parametric geometry. Then we will apply daylight simulation, and then will be later taken into optimization. So the result should meet the evaluation criteria I showed before. And if it doesn't meet the evaluation criteria, those geometry will be taken back to the parameterized facade, and some modification will be taken. And again, it will be taken into the same workflow until we get the answer yes. And if we get all the answer yes, all the solution that fulfill the visual criteria, then we will consider, okay, this is our final solution. So let's begin with parametric modeling, which was made using Rhino 3D and Grasshopper 3D. For the room, I actually took a room of 9-meter depth, and width and height was for 3 meters. It was an office typology, workplace, and open plan interior. So I tried some of the possible parameters for facade, and you can see here some of the options which are like no number of columns, uniformity, similar rotation, non-uniform rotation, non-similar arrangement. So all this were tested, but to simplify the design process, I just chose 3 of them, in which first was the rotation, which was separated by row. Each rows can be rotated separately. The second was module type that can change individually based on all the 8 options that I showed before. And the third one was material set. I gave 2 different material set on the top and the bottom, and that can rotate at 180 degree to give different kind of properties. And this geometry, after parameterizing, it was taken to daylight simulation, which was done using Honeybee and Ladybug. And here you should understand one of the thing, which is the diagram of how to read the diagram of this daylight distribution. So the red portion here shows area where lux level are about 2000, which creates glare. And this red area can also be said to overlit area. On the other hand, the dark blue represent area with lux level less than 300, and it is said to be underlit, which creates blindness. And all in the between the gradient within daylight range with different intensity of lux. And the value below image represent illuminance value, which is 2805 lux. And the second image shows only 2 different colors, where gray represent the useful area, which falls within 300 to 200 lux. So it clearly indicates like white area is what we need to achieve, and this white area needs to be all over the depth. And the black area shows either it is about 200 or it is below 300, which we don't need, which we want to avoid. And the percentage shows like how much percentage of the floor area is useful, which is needed for us. So I made some of the simulation without my design facade, just to understand like at different time how the daylight is actually acting in this same space. And after setting up the design daylight simulation, I took this process further to optimization, which was used using a tool called Wallaki. So here you see, like, I found some of the final solutions from the optimization, which was using the facade with different configuration for all the 12 instances. And this shows without glazing. So you can see in both of them, like in the final solutions, the red area was almost neglected and the blue area was reduced at a large space. And if you see on the other diagram, like you can see like white area has been increased a lot. So this actually shows the whole computational workflow in a summary that was used in my thesis to get the optimal result. And at the bottom, you can see the whole, like all 12 facade configurations for each of 12 daylight instances, which had different zones. So after this, yeah, that workflow actually used the Grasshopper script that I made to achieve that kind of result, and to prepare that workflow is displayed on the screen right now. And yeah, you can see one of the same kind of a GIF that I prepared, like how this adaptive facade will react to the motion of sun. So as sun changes its altitude or azimuth, the facade will like take its position, an optimal position, to give like a good daylight inside. So along this process, a conclusion was derived on facade performance about relation of facade's feature with external factor as well as indoor behavior. So it was found that changing sun's altitude was diversely controlled by rotation and was responsible for controlling daylight reach. So here you can see like how this range is getting increased just by rotating itself. So like the daylight which used to reach until here, but with this facade, it was reaching until this depth. Second was the changing sun's azimuth was diversely controlled by folding and unfolding and responsible for uniform distribution. So while changing the azimuth, this module were taking its own shape, which was actually creating some kind of a uniform distribution, like reducing intensity from the front, like reducing the red part, and increasing the intensity at the back, which was also reducing some of the blue part. And you can see some of the configuration that was being used for the simulations. The third one was change in sky condition was diversely controlled by different material set, and it was responsible for controlling light enhancement. So one of the material was with low intensity, and the bottom material is with high intensity of reflection. So if we just change those material, like this light intensity can go from bottom to top, and you can see here like it was increasing almost about 4%. So that's how like some of the results were concluded and achieved. And I also plotted the graph of intensity of light throughout the depth for each of the configurations. So you can see here the gray light shows like without facade how much was the intensity. So if it is going up, so it means like glare is being observed here. And if it goes down below 300, it means like it was it somehow creates some kind of a blindness. But you can see using this facade, it actually helped to get down the intensity of light at a greater extent. And at the back, it was actually helping to also uplift some of the intensity of light. So you can see in all of the examples, some of the similar kind of results were obtained. And overall, a homogeneous flow was achieved throughout the depth in each result, which actually shows that what I was aiming for was achieved. And similarly, this is for another configuration for the winter condition. So all the results data were actually noted in a table with different kind of a evaluation criteria. And we can see, so after concluding and calculating all the information, an overall result of 88% of daylit area was found. And it was having 561 lux as an average illuminance. And the requirement was to be between 300 to 750, which I achieved. The uniformity ratio should be more than 0.3 as per BREEAM. I achieved 0.57, which was also a positive result. And it was having no risk of glare and no risk of contrast throughout the depth. And so based on this, gaining this result, it was finally concluded that a visually comfortable environment within that room was achieved. So average illuminance of 561 lux, which is close to 500 lux, and it was the requirement by CIBSC for the office, which was achieved. Uniformity ratio, as per BREEAM, it states that it was required to have 0.5 to 0.7 for artificial lighting, whereas my facade achieved a ratio of 0.57 through daylighting. So this concluded that I successfully achieved a homogeneous distribution desired by artificial lighting, but by avoiding artificial lighting but only with using my facade lit, and you can achieve that kind of a homogeneous uniform distribution of ratio. So use of artificial lighting can be directly neglected. So this came to some kind of a decision. And also on the other side, like daylit area was achieved for 88% of the floor space. And with that, like artificial light can be reduced by 80% throughout the year. And this reduces lighting consumption by 88% overall throughout the year. So after getting the evaluation criteria and the result, like now the time was to take the facade in detail mode and have to do the feasibility checks. So the facade was given 3 different modules. One was the PV modules. The second was a reflecting module with 2 specular material to reflect light. The third one was diffusing module with 2 rough material to diffuse light. And the rotation mechanism for dynamism in facade was actually given by a rotary actuator. And a folding mechanism was done using linear actuator and 3-link bar mechanism. You can see here, like it shows like a folding mechanism and the unfolding mechanism. And a sensor system was proposed to which will actually send the sensor signal to the processing unit, which will again send the signal further to all this actuator, like which module have to move where and which module have to fold and unfold. And based on this, different kind of positions of the facade can be achieved, which could be a neutral state, performing state, and closed state. You can see here some kind of visuals. And at the end, this facade was also compared with the existing example, which is Al Bahar Tower, Dubai. Maybe you might have seen this tower, which is also a dynamic facade. So it was found that the facade lit was almost 53% lighter than Al Bahar Tower. So which can be mean that 50% the cost required for facade lit would be 50% lesser. And based on some of the research, it was found that facade lit was actually performing 48% higher than how Al Bahar Tower is actually performing. So that's how I actually concluded one of my project. And I will actually give one more example on performance-driven design. And this project was actually based on a competition released by European Commission, which is LOI 130. And it was a multifunctional complex for European Commission. The brief was to design a mixed-use complex of floor area 198,000 square meter distributed amongst high-rise, low-rise, and mid-rise. And the program included office, housing, retails, and recreational facilities. So the main objective of this project was to integrate approach to create an energy efficient and sustainable design outcome. So I won't be covering the whole project, what we did, but like I will be showing the main aspects that will be showing how performance-driven design was actually applied to such a big architectural scale of project and how decisions were made. So usually we start deciding on some of the basic ideas and we begin like that, so in similar way. So our thought was like the structure was gonna be the biggest or the tallest tower in Brussels. So the idea was that to make this tower more iconic and by bringing both tower close to each other. So for locating and finalizing massing of high-rise towers optimally, we ran some of the optimization in Grasshopper for the most optimal distances, for most optimal rotation and most optimal shapes. And we actually ran this simulation based on some of the objective in which we wanted to achieve a balanced radiation on each face. We wanted to have like good daylighting on each of the surfaces, and due to wind, the structure should be lightweight. So somehow we achieved the result for our tower. And the second thing was to bring a massing design for the low-rise and the mid-rise towers. So here, like we arranged it around the tower, the low-rise and mid-rise massing. And the idea here was to bring sunlight inside the central plaza. And the main idea was to bring that sunlight because it was an office space, and in the afternoon, people used to go downstairs at the ground floor to have the lunch. So we needed direct sunlight for that space in between 12 p.m. to 2 p.m. So how we can achieve that? So we actually arranged the cube massing all around the space. We actually threw sun rays from 12 p.m. to 2 p.m. in that plaza. And all the sun rays which was actually intersecting to the cubes, we actually removed those cubes. And somehow we reshaped those modules based on our design principles. And that's how we could actually achieve 2.6 hours of direct sunlight into the central plaza. So this is some of the approaches how you can achieve the results which somehow you can quantify it and somehow you can justify it. And finally, we achieved a final massing from this two different approach. And then like a program was distributed for the massing, which had offices, housing, recreational area, retail, as I already mentioned. And after actually having the final mass, still you can actually do more analysis and do some kind of a design decisions. So first one was radiation analysis, in which we did some radiation analysis to understand like which surface has more potential to put PV panels. So while designing facade, we actually could arrange PV panels to those surfaces where we can get most out of the result. So doing such thing, we could achieve 34% of offset by just using PV panels on the surface. And you can see yellow portion where we used the PV panels. The second was to create some kind of a comfort level for pedestrian at the ground floor to neglect wind tunnel effect. So for that reason, we actually applied wind analysis, and somehow we could optimize massing based on the wind stress on that mass and could achieve a comfortable pedestrian experience. The third one was to understand like how the traffic actually affects the massing in front of it, because traffic can actually produce some kind of a noise and pollution. So we also did some kind of a acoustic analysis like how this traffic can act on the surfaces. So based on this, we came to a decision that green facade should be the could be the best solution for this, which can actually help to reduce the noise and can reduce the pollution from the street. So this was some of the performance-based decision that we made into this project. And one of the place where I worked, which was OMRT as a computational specialist, we did several kind of performance analysis for different scale of projects. So I will just run through you like what different kind of analysis can be possible at different scale. So building scale, different kind of analysis that could be done are like daylight analysis, energy analysis, CO2 analysis, radiation for PV yield, PMV comfort, which is like microclimate. And this can be done just to have some kind of a design decision for a refurbished building or to build a new building. And based on this different analysis, you can also do different kind of an optimization based on your own requirement. So one of this project in which we only had to optimize the shading elements. So we ran all this analysis just to optimize shading based on all these different aspects. And also you can do simulations and some kind of a decisions making for urban scale projects, which includes wind analysis, some of the acoustic analysis, UPCI, which is basically urban heat island, shadow analysis, view to sky. And here, usually the idea was to perform analysis to make further decisions. But here it was completely from scratch. So we had to create different massing options using, again, generative design. And all different kind of simulations were applied to all different kind of options. And after that, we came to a decision that which option is working well. So that's how this whole process of the performance-driven design goes. So we did talk about performance-driven design. So this performance-driven design actually helps to optimize the operational carbon when you are using the building, when you are using electricity or HVAC or some lights or some kind of an equipment. So usually operational carbon accounts for 80%, but there is another carbon which is called embedded carbon, which actually accounts for 20%. So even after getting high performance building, you cannot optimize embedded carbon. So what about the building itself? Like after optimizing the use stage of the building, but what about the building as a material? Like what about the carbon footprint that has been released in creation of the material that has been used in building? And what about the whole embedded carbon of different processes like transportation, production? So what is the next step to go beyond performance-driven design for sustainability? So it again leads to one of the next topic, which is called carbon negative design, and which is actually combination from both like operational carbon from last topic and the embedded carbon, which will be covered in this topic. Let me begin with like understanding like what embedded carbon is. So the construction process usually include like 4 different stages, which includes product stage, construction stage, use stage, where operational we saw is a part of this stage alone, and the end of life. So each of this stage, the energy is being used and greenhouse gas emission is being released. So how can we account for such emissions and what ways are there that we can reduce it? So this answer for this is simple. Like we should use less material. We should use local material or bio-based material or recycled material or material with high recycle content, or even a carbon sequestering material, which is like wood, who throughout the lifetime they actually takes carbon. So that's how we call it carbon sequestering material. And to use renewable energy, even for production of the material, not only for the electricity of your own houses. So I will take you through one of the projects that we did in our university, and the main objective of this project was to study facade of the existing educational building in Utrecht, Netherlands, and redesigning a facade based on issues from existing condition. So the challenge was to make redeveloped facade more sustainable and easily replaceable. So the existing facade was studied and analyzed for carbon emission, where each component of the facade were taken and calculated by weight, then multiplied each component's weight with its carbon value per meter square. And when plotted the graph, it was found that aluminum shading element were observed to have the highest carbon emission value. So this led us to a decision in which we wanted to replace aluminum with more carbon negative material, which we took here as a wood. And new design was prepared where shading element was stacked vertically, again to avoid sagging of the louvers. And this wooden planks were twisted 90 degrees to create opening for light penetration inside and view to outside. So that, and even after that, like a second layer was added by infilling the growing creepers, which had a purpose of providing thermal comfort that can adapt with different seasons. So in summer, the plant experiences growth, and which will fill some of the gaps within, and this will block incoming of harsh sun and reduce heat gain inside. Wherein, like during winter, the plant experiences fall of leaves. So this will actually free up the gaps in between to allow direct sunlight for the heat gain, which is actually needed for the winters. So somehow this kind of things were dynamically achieved, which was adaptive to different seasons. So after finalizing on material for each elements, the redeveloped facade was calculated for carbon emission using manual calculations here. And this were compared with second skin of existing facade. A notable reduction of about 75.9% was achieved. And usually like this approach is taken in a way that like all different components of the facade system is separated based on different materiality. And each material have different embedded carbon and embedded energy and carbon footprint value. throughout its life cycle, how it is made and what will happen after its end of life. And so basically the idea over here is to gain volume of all these different elements, multiply those volume by carbon footprint and embedded energy, which is per meter square. And this will actually give you the value, how much carbon intensive your facade or your design is. And when you do a summarization, it will give you some kind of an idea. Okay, this is something that you want to reduce. So by just changing few materials and some design strategies, we could actually achieve on an average of 76% of reduction in carbon itself. So with similar kind of approach, you can actually quantify your result, and using right material, you can reduce embedded carbon from its construction stages. But now what happens after end of life cycle of any building? So basically the construction waste goes into landfill and increased dumps. So what can be done at the end of life cycle of the building to avoid that, and how can we avoid the construction waste to landfill? So yeah, what is again the next step to go beyond optimizing embedded carbon for sustainability? Is it anything that we can do after that? Yes, so it will lead us to one more topic, which is circular economy. So basically this process of going from construction stage to sending material to landfill is called linear economy, where actually steps are in just one linear way. But instead of sending material to landfill, we can add one more stage of recycling and reusing, demolishing material and bringing that in front of any new construction. So this somehow completes a circular cycle by circulating used material and avoiding making of new material, which will again avoid the creation of new carbon emission. So this is the diagram that was actually presented by Ellen MacArthur, which shows two different cycles, biological material on left and technical material on the right. But today we will be focusing on technical material. So basically what this indicates is, before sending any material to landfill, it should be sent back to individual manufacturer for maintaining, reusing, refurbishing and recycling of that material. And depending on the condition of that used material of product, used product of the material, that you can actually recirculate into the different manufacturer. And at the end, when it's of no use anymore, then only it goes to landfill. So you are actually saving several cycles of carbon emission into this. So one of the so circular design is actually one of the part of circular economy. And this diagram will just illustrate you one of the example where a flat plate from new site is taken to the site, it assembles it, and it is bring into a complete new construction. And after the end of life, this construction is reconstructed. Again, this separate material and component are actually collected in a material storage, which can be taken further for a construction of a new configuration or maybe for the same process. So somehow it creates some kind of a circularity here. And I will show you some of the circular principles which are actually important in designing of circular design. So one of the main point is design for disassembly, use of recycle and repurpose material, modular construction, flexible and adaptable, and should be easy to construct and deconstruct, which can actually reduces the labor cost. It should be easy to replace, which actually reduces the maintenance cost. And joinery detail should be with bolts and screw, which we can open and refix it. And we should avoid welding and rivet joints on such kind of a construction. So again, circular design approach was actually made by me in the same project I showed you, like my thesis. So I will show you of the my thesis in this section. So you saw that a dynamic facade was created, but this facade was actually also were designed in more detail, in which I designed all different elements separately, which can be disassembled from each other, and all the joints were given with either screws or bolts, and they had like different layers. And this can be also again like taken further to some new construction or the replacement of the similar kind of construction. And similar way on modular scale too, each component of this module was designed for disassembly. And basically this page will show like all the state of assembly sequence where going from assembly sequence in the front, and if you take disassembly sequence, which is in the reverse order. And it was actually designed like an IKEA product where actually any unskilled person can also assemble this module, and also assembly manual was also prepared, which can be useful for any viewer. But now later, after having or designing this circular design, how do we now quantify this? Like, how do we quantify like how much of our design is actually circular? So it has like a very common approach to carbon calculation. So here you have to again like calculate the volume of all different elements. Like I took here like for the module and supporting structure both. So you calculate the volume, and after having the weight of this modules, you just have to, what I did was like I listed all the component based on the possibility of its demountability, recyclability, and direct reusability. And after having that information, I actually simply just took the percentage of such components to overall weight of the facade, where I could conclude that 98% on an average of my whole facade was demountable, recyclable, and directly reusable. So a holistic approach to sustainability is when you apply all this principle in each project together with each other. And such approach will help us to achieve targets to avoid global warming, which is getting worse in such a climate emergency. So is there any next step to this? It's still a question mark. Thank you. So you are free to ask any questions that you have, and I'm sharing you my contact detail as well, so you can save it and you can reach out to me anytime on email or LinkedIn. So yeah, you are free to ask me any question.
Hello.
Hi.
This is Rusha here. I just wanted to ask, what kind of softwares are there for just designing or simulation processes? Like, what softwares we can use?
So basically for what, like software for simulations?
Yes, yes.
Yeah, for software for simulation, like one of them is like Grasshopper, and they have like different plugins. And let me show you. Yeah, so here like you can see like for parameterizing, like you can use Grasshopper, but like for different kind of simulations, you can use like Honeybee and Ladybug, and which will actually give some kind of result based on some kind of a visual appearance as well. But there are also like many external softwares for daylighting. You can use DaySim or like Therm. So those kind of things are also available. But Grasshopper actually provides you the opportunity to have everything in one single platform. And it also allows you to optimize your design based on your different kind of criteria. And even for optimization, there are like several tools available: Galapagos, Octopus, Wallachei. So all these plugins are like free to use, and they can be directly linked to Grasshopper. So you can also try that. And there is some other list I will show, like how these different simulations were used. Okay, so here you can see like here, like, yeah, daylight analysis was used using Honeybee and Ladybug. Most of them were like used with Honeybee and Ladybug. Like CO2 analysis was in-house prepared, which we just used like some kind of a mathematical components from Grasshopper. And here for radiation, you actually additionally need radiation. For comfort level, you need OpenStudio. And maybe for like wind analysis, you need Energy Hub, which is like CFD, FFD. And for acoustic, you need like Pachyderm. So these are like different kind of plugins and tools that you can use for different simulations.
Okay, thank you, sir.
And I think like there are like several, like tutorials available on YouTube, and there are also like prepared scripts that are available online via like from the owners of like Honeybee and Ladybug. So you can actually directly use them, you can learn them, and you can apply those things on a very, very basic level in your design, like very simple simulations, which can actually help you to understand like how you can take your design decisions further. So that's how you can go much into deep things.
Yes, sir.
Uh, Hello, can you hear
Yeah,
me?
yeah. Go ahead.
Uh, so while we're on the topic of discussing applications, I wanted to know whether you came
Sorry, I
into
can't hear you clearly. Sorry, I can't hear you clearly.
yeah, now can you hear me clearly?
Yeah.
Yeah, so while we're on this topic of applications, I wanted to know if you came into using these applications after you joined your master's, or was it that you were particularly interested from the beginning itself and you self-taught yourself all of this? So how does it go for from designing to using these applications for designing?
Yeah, so usually this all this principle I learned after going into masters. For design level, I would say like I saw when I was in TU Delft, like people used to do some similar thing from bachelor's. So I think like on design level as well as an architect, like as a bachelor student, also like you can implement some of this techniques into your process or your workflow into your design. And I think like somehow this will also help you to take a decision further for your next step after bachelor. And even though you might not want to go further into this, but this is something kind of a knowledge that you should be knowing at least to integrate into your design, even with a help of some kind of a different consultant or someone. So I think this is something which actually helps you to, like improve your efficiency of the design. So that is the main purpose of having this kind of strategies.
Okay, okay. And one more question.
Yeah, go ahead.
How did you go actually from building technology as your major and then into sustainable consulting?
Yeah,
How
so
was
building
that?
tech. Yeah, okay. So basically, TU Delft has all course based on sustainability, like the university itself practice sustainability. So we do know many things about sustainability throughout our project, even if it's urbanism or like building technology. And the current role that I am here doing are very similar to what I learned in building technology, and all this different approach that I showed, which actually aligns with what I have learned in building technology and what I am currently doing here.
Okay, thank you so much.
Yeah.
Good evening, sir.
Good evening.
Sir, this is Manushi from currently studying in fourth year.
Yeah.
Sir, I wanted to know your experience with Foster and Partners because we have heard a lot about Foster and Partners and wanted to just know your experience.
Okay. Yeah. Well, of course, like I cannot say anything bad because all experience over here is amazing. And yeah, like whatever you expect from outside, yeah, like when you come inside, it's way more exciting. And I think like I don't know, like if you are in fourth year, you might have been into internship already.
Yes, sir.
Yeah, so when you go to the office, you need some kind of a motivation to work. Sometimes you don't like the project task and stuff. But I will say, like as per my experience, I just only hear my name and I get excited. So that is what one of the good part of here. And everyone in Foster and Partner is actually very transparent. Everyone knows what everybody is doing, which usually doesn't happen in India. I think that is one of the disadvantage. You should always keep sharing. We usually, even in the university, even in my time, we used to like hide our design so nobody can copy it. But I think like as much as you can share your ideas with each other, you will get more and more knowledge. And one of the other thing I will actually suggest is like try to keep your approach diverse. So Foster and Partner has all different disciplines within the same office. So we get to work on the same project with different expertise. So we get a lot of knowledge from them. And that's how we can understand, okay, like how each building has been, reached to its like maximum potential. So I think it's work of team and yeah, a good diverse discipline of knowledge.
Okay, thank you, sir.
Yeah.
Hello, sir. This is Pankaj. I wanted to ask, how is your approach different as a sustainable designer compared to your colleagues in Fosters and Partners?
Sorry again. Like how my approach and
How your approach as a sustainable designer is different from your other colleagues in the firm.
within the firm.
Yeah, within the firm.
Okay, so well, there are different categories. Like there are designers, there are sustainability designers, there are facade designers, landscape, urban designers. So within sustainability designing, we have very diverse team. Like we have people from engineering, architecture, and yeah, like from civil, even from mechanical and chemical. So what I showed is like very introductory. Like each topic can go way more into depth. So there are some people who does maximum of research. There are people who does like analysis. There are people who does mostly kind of a design strategy or designing. And I will say like my task is not different than them. Everyone has to go through each task, but sometimes like you have like more expertise into something. So you get more of those tasks into your hand. So for me, I'm getting more into like a designing task, and there are people who are more expert in analyzing or researching. They get like such kind of task. But you have to do everything at certain period of time.
Okay, so it's like the same workflow that we find here, is it?
Sorry?
Like you start from, is it the same workflow that you start from designing and then go into the detailing of it and then sustainable?
It depends. It depends. Every project has a different approach. Every project has a different approach, and right now the time is to have such kind of decision at early design stage, not to wait for when your design is finished. So one of the example that I showed uh, is something that you should do. So this is how we started our designing. Like we had our own generalized idea, what we want to achieve. And just to justify our ideas, we went to do some kind of a simulation and got some of the result. Sorry. So not only performance driven design, I showed example in which like in one project, I showed only one approach, but each project has been gone through all the approaches that I have shown. So that's how you somehow achieve what you want to have. And I will actually suggest like if you are designing something new, you should think everything in early stage design.
Okay, thank you so much.
Yeah.
Hello.
Yeah.
I'm Kautuk Chaudhary. Currently, I'm in final year.
Yeah.
So I wanted to ask about, if we see current situation over here in India, at least, such concepts of sustainability and this kind of design approaches are only done where the big companies are building and construction, doing construction works over here. We find a really hard time to design in such a manner for normal residential or office houses, office buildings.
Yeah.
So how do we try to tackle those kind of situations for small projects?
Yeah. Okay. So the first of all, like first thing I will definitely say is like you should take your own responsibility. You shouldn't see like how people is progressing, how they are doing. Like we know it's climate emergency, and if you think we should definitely act on it, if you think like this kind of approach will actually or will make a difference, I think it's you who should do it. Like all the project I showed were mostly done by me, like a single person. So I can say if you have like even a small team of like 2-3 people, I think you can actually put an extra effort of doing such kind of an effort. And most of this approach were not taking much of the time except optimization and simulation side. But like replacing material for carbon content, it's very simple, and I think you should definitely go further for it. And other thing I would actually want to add here is even if you think of the small houses, so there are this is one of the experience I got from my experience when I was working in Ahmedabad. So there are clients who want to showcase their houses to their guests. We did something like this. Like people say some of the people, they don't have money, but like they put money behind just increasing the aesthetic value. So there was also one of the client in my office where I was working with who actually provided a kitchen of about 1 crore just to show their guests, and they had another kitchen for the cooking. So I think maybe it's our responsibility to show them. Guest come, the house owner should show, oh, see how warm it is outside, but inside if you sit here for like long 3-4 hours, even in the night, it's still a good temperature. In winter, if it's cold outside, you should show your guests if you come inside, you will see you will feel still warm. And if they stay in your house, you should tell them even if you stay in the evening at 7 p.m., you can still have the daylight. You don't have to use artificial lighting. We are saving so much of energy into this, and we have used all this clean energy, renewable energy. So that's how people will get engaged into it. And another thing is, you are lacking behind because there is no policy, there is no restriction that you need to have this. If there will be a policy, I think everybody is going to run behind it. So this, there are many different kind of segments that you can think of, but I will say the main thing is you should take your own responsibility to have this kind of approach into your own workflow.
Hello, sir. I am Riddhi. I have a question.
Yeah.
Sir, there are certain stereotypes about design, like how sometimes dynamic or parametric designs are categorized as being corporate-like, or maybe they are generally used in offices or other public use buildings. So, sir, are there any ways where we can break such stereotypes so that all these solutions can be applied to other designs as well, to make all of the designs that we make performance-driven?
Yeah.
Like how can that be achieved, or is that possible, or is it there is still a long way to go?
Like every different location, every different place, and every different design requirement has different approaches, I will say. And based on those approaches, you actually have to brainwash your own self, brainstorm your own self, in which you can think which of the approach you can apply to different designs. And there are many approaches that I showed, even if you can't able to achieve all of them, maybe you should start with one of them. And also one of the thing is I won't say that you should be focusing on the final result right now. You don't have to think of achieving the most neutral, sustainable building or the most optimal, but at least take a benchmark. If you don't consider anything, what is your benchmark of that design, and how you can even improve it for 20 to 40%. And even if you are doing that, if not whole building, but even if on the south side, on the same face, on the one facade, you are changing it and it's making a difference, I think that will also contribute into what you are doing into sustainability. And time to time, design wise to design time, every project you will get to understand, and you will develop your own workflow, you will develop your own ideas, and you can integrate more things into the same design afterwards. It will take some time.
Yes, sir. Thank you, sir.
think I can come in now since hands are raised. Akash, I have 4 things to ask. Both from your presentation and to our
Sure.
they are in general. One is
Yeah.
you showed one graph where it has been depicted that operational energy contribute more than the embodied energy, right?
Yeah.
So, I mean, I always thought that embodied energy will contribute more. So, in embodied, you have considered the entire LCA from extraction of virgin material, transportation, manufacturing, then again transporting to the site.
Yeah.
So, all of them
Basically,
together contribute lesser than the operational energy.
yeah, so I will explain. So basically, like embedded energy was less here because the embedded was until construction, but after construction, the building life cycle was taken for 60 years. So in the period of 60 years, there is only the carbon that has been generated from operational stages. So somehow summing up those 60 years of operational carbon takes it even higher than embedded energy.
And maybe because there you are highly dependent on artificial
Definitely. Yeah, there is no
like
renewable energy.
in India we have more passive techniques and we are not very much reliant on ACs and other mechanical devices. Probably that because for India I know that embodied energy is higher than the operational energy.
Okay,
But
so
yours is
maybe
also an
that could be the
option.
context difference here.
Okay.
Yeah.
My second question was
Yeah.
initially you showed like different you had selected few facade designs and then you zeroed down to 3 or 4, right? But all were horizontal.
The parameters you're talking about. Yeah. Let me share.
No, the device. The facade.
Yeah.
All the facades are having horizontal movements, right? None of them are having vertical.
This one, right?
I cannot see your screen. Are you? Yeah.
Yeah. Everyone is horizontally stacked. So one of my conclusion, which actually wasn't in the scope of my thesis, but in the end, actually, I concluded from my research and from my readings and my experience that on the south facing horizontally stacked louvers works really well, and for the west and east where sun position is super low, that is where and it's also slanted, so that is where you should keep vertical stacking.
Okay, and you have taken only south facade.
Yeah,
Like
this
for
is only south. Yeah, that's why I only consider like horizontal. So there was also one of the limitation in this thesis that during a very, very lowest sun position, there were like some of the glare dots that were coming inside. So that's how like I went further to research, and that's how I came to know, okay, like for lowest and slant sun angles, like you need to have a horizontal. And when it is just like a direct, like from going from top to bottom, then I think horizontal works well.
Okay. Yeah, so this is from your presentation. The other two are when we are talking about India and the attitude of the people, that why are we not very sensitive towards sustainability? I guess, and if at all we compare, because I heard you saying यहाँ पे like here we do stuff like this and stuff like that, but India की तो problems ही अलग है, I think. There people सबके पेट भरे होते हैं ना, and you have a certain level of lifestyle, then things are different. So I think India का सबसे बड़ा problem is population.
Yeah, that is the main thing. And the cost, economy. Yeah.
Economy, yes. So I think हमारा अभी policies इसमें इसलिए नहीं है because हमारी priorities are different.
Yeah,
Hopefully,
exactly.
Environment will be a priority soon. करना ही पड़ेगा, not an option. But it is because most of the people, they are still coming on the edge of, affording few things. So they just want to boost up, show up, because इतने साल तक उन लोगों के पास ये था नहीं. So it is more about the attitude and what people have been enjoying till now. So अगर हम जैसे हमने ना बहुत टाइम गाड़ियों में घूम लिया होता है, then we don't. I mean, it hardly matters whether we drive or not.
Yeah.
But in India, I think things are pretty different.
Yeah.
And the last point is when you are discussing or you are sharing your experience at Foster and Partner, and you mentioned that interaction with other teammates, and being transparent is very important. I
Yeah.
guess all of our students also need to understand this, because the interaction is completely going away. Students are not
Yeah.
interacting within the class. Senior junior to chhodi do. And I would like if you could
Yeah. I will add like
tell them
points here,
the
like
importance of interaction, make students better.
yeah. So like the first point I will say about like yeah, India, like you said, like the economy and the population. Yes, that is the lowest answer. Like when you like sometime I also think like the difference, like what is difference, what is creating such kind of a difference. So I end up only with this kind of answers, like yeah, population and economy. But I like my main focus today was to aware student about this kind of approaches, because I have studied in MSU, and I know like I was only like mostly people are only focused on functionality and design, but they don't even focus on other service subject or anything like structure or anything. And I know that like many people doesn't even know like such kind of course or such kind of principles exist. If you know, that's good. And one of the thing like on top of this, I will tell you like there are many new terms I have been used in presentation. So don't be scared. Like this is something which is like of course a master level, but the idea was just to show and introduce you like this kind of something is happening, this kind of something is actually existing. So yeah, so now like after your bachelor also you can take your decision for your masters, or like even if you want to do something regarding this. And mostly I have seen like people also are aware about like masters only like in 3 or 4 different type of terms, which is like architecture, urbanism, or landscape. But there are even more and more of different field that can be that can have like similar kind of opportunities. So there was something. And about that, like in India, like if you want to change it, like of course like a student, as a student you have to take that responsibility of having such kind of approach into your own design workflow, and to understand how we can change and improve our design. So all this thing will actually help you to make your design decision, and will actually makes life more easier. Like if you just think out of nowhere, it will become a little bit hard. But if you have something concrete, like, okay, like this is actually giving me some kind of a result, this is it. Like you can justify it. There is no one else to talk to you about. Like then no faculty will comment you like, oh, why you have given this. So that is something also you can avoid. And about the second part, which is interaction, I will definitely say like interaction is really, really, really important. And like it was a drastic difference when I moved from MSU to TU Delft. In TU Delft, even it was first day, even if you are designing anything, even if you are sketching something, everyone will share to everyone. They are like completely open what we are doing. But you should have to be truthful to yourself. Like you shouldn't copy it. You should be looking at in a different perspective, in a way that like, okay, like this is where I should also think about, like we can go more beyond that. And all the project in TU Delft was mostly a team based. And at Foster and Partner also, like we are working as a team, there is no individual role. So for team work, you have to really fuck up, and everyone has to have like diverse skill. I already mentioned it. And you should know like how to distribute tasks, how to share ideas, how to reach the potential, even if you are like in team, but even if you're like working remotely, but still how you are connected with each other. So even in that team, like communication is one of the biggest thing. And even if you give the interview to any big firms, they will definitely check your communication skills. So everything of this kind of skill is really important. Yeah, Chetan has raised his hand. Go ahead.
Chetan sir. Chetan sir, yes, you can go ahead. For the students here, Akash was always a very sincere student. So, and he was very disciplined. Sometimes I used to wonder, वो ऐसे कैंटीन में बैठा रहता था, and still, I mean, I remember उसका sketchbook होता था उसके हाथ में हमेशा. So, but I also remember that he used to enjoy a lot. We festivals तो बहुत enjoy करता था.
Yeah.
That is what I always ask students, and you should have mix of both. पढ़ाई भी उतनी करो और साथ में लाइफ भी एंजॉय करो. ये लोग एंजॉय करना चाहते हैं तो फिर पढ़ाई भूल जाते हैं.
Yeah.
चेतन सर. Sir, you are muted.
I can't unmute. Yeah. Okay.
Now you are.
Now
audible.
fine. Akash, good to hear you. As you said, you have to educate your client, and I have been advocating this about circular economy to few of my clients.
Yeah.
But having a smaller practice, probably, I mean, I have not received so much of response from them. But I have been advocating this since many years now, 4 to 5 years. Another thing I wanted to know is Ellen MacArthur Foundation works with your Norman Foster? No.
No, it doesn't. Like she is, I think, like a researcher, like based completely on like circular economy, and like she does not only for architecture, but like also for like a food cycle and everything. So like, yeah, she's like completely into.
Yeah, I know. I have been in touch with them, and I have been writing also to them many times.
Yeah, so like no, she is not directly in touch with Foster's.
Yeah. Okay, fine. Thank you.
Yeah, thank you.
Hello, sir. This is Devanshi.
Hi, Devanshi.
Sir, I had a question that apart from software learning, how can we start learning computational design?
Apart from software learning is kind of a tool that will actually allow you to do stuff. But behind software, like software is not a human, like it doesn't have a human brain. So what to input into software, that is all up to you. Like all the process that I showed, like which facade options that I created, from those options, what 3 options I selected, how this design should be, like all those decisions were like by me. But you have to, like even in here, like you have to understand the integrated approach of how software works and how your brain, like what your brain needs, like what you're aiming for. So you have to think in that way, like if I put this into software, like will it achieve that? But before that, like to understand, before going or getting into software, you have to study some research paper, how people have taken different approaches. So if there is a high-rise building, like in what different ways a high-rise can be optimized. Like, so I only showed like daylight, thermal and all this stuff, like building physics stuff. But there is also a part where like people do optimize structure and forms. So, like you should know like what different ways we can optimize, what there are different parts. And then your brain will start working towards that direction. And when you are like in front of the software, then you will be okay, like now I have to apply this approach, and I want my objective is this, I want this result out of this, and you will be able to do it.
Thank you, sir.
Yeah. Parekh has raised his hand. Neil Parekh.
Hello, sir. Good evening. I am Neil from 4th year. So I had a question that in your initial slides of the presentation, I saw a comparison between different, the rating systems which our organizations are providing to us when we build the buildings. And so here in India, we have IGBC, and also we recognize many things from, US Green Building Council and all. Here, from recent times, many developers and the companies have started being in competition by getting that ratings and all. So I saw the comparison that even if by achieving all these ratings, we are still far away from the global that issue which we have to recover. So how at at Foster and Partners, how do you see such things? That what are your major calls to achieve these kind of things at your institution there?
Okay, so I will say like for certification things, like of course like that are not enough. So people are actually pushing it, and now on the global scale, all different kind of policy are actually trying to reinitiate, like not reinitiate, but like some kind of a modification or like new policies that should be in advance of this. Like one of the certification was recently launched by LEED. So LEED Platinum was the highest rating, but they are now launching LEED Zero, which will help you to achieve, I think, 2 degree or 1.5 degree. I'm not sure, but yeah, like that is something that they are developing now. So current hot topic discussion all around the world is embedded carbon and circular economy. So they are still developing the policy. The other thing I will say, like how Foster and Partner is trying to achieve is, so like you said, like you have IGPC and all this rating, of course, like we have in India. So they will also take some kind of learnings from all around the world, like what is happening, and compared to like many countries like USA, like India is not into that kind of an emergency compared to USA, but whole world is, but compared to USA, it's not. So they are still developing, but one of the approach that Foster is actually taking, because they have pledged to do carbon neutrality by 2030. So they have taken a decade of plan. And another thing is like we are actually focusing for -1 degree Celsius. And that's how we are trying to achieve 2 degree to 1.5 degree. But at least 0 degree is our target.
Right, sir. Right.
Yeah.
So here also, if we at the initial stages of designing as a student, if we see such criteria, then
Yeah.
what do you think must be prioritized firstly? So there are multiple criteria, and according to, of course, they are according to the region or the location or
Yeah.
the geography. But
Yeah.
still, what do you think that the criteria must be prioritized first?
Okay, so I will say like a criteria for like the simulation part you can definitely do at home. Like that can be something you can achieve like for some performance. The second part was like embedded carbon. It's just matter of like replacing some material. There might be issues where like wood and such kind of stuff are like expensive, but there is a replacement from stone or like any natural material. So that would be second thing you should think of. The third thing is for circular economy, maybe even if you don't achieve all the principles that I showed, but even if you can partially or hybridly do your design in which half of the design, at least you can disassemble, like it shouldn't be like fixed design. So even if it can be disassembled, it doesn't goes to landfill. And even if it's steel instead of wood, but after end of life, that steel is going to get used in another project. So somehow you are avoiding the carbon cycle and you are actually reducing that carbon, even though that is steel, which has higher carbon content actually. So, like this, like small indications of principles that you can apply, I think, to any design. So you should start your thoughts with at least one I already mentioned, and you will get there like slowly, like how to get into all this kind of principles.
Right, sir. Thank you so much.
Yeah, welcome.
Does anybody have any other questions? Okay, so I think we can conclude this session now.
When we generally talk about sustainability, the only thing that comes to our mind is traditional materials and construction techniques, going back in time, staying away from new technologies. But as per the information and projects you shared with us today, that's not always necessary and that's not the only way. A fusion of the knowledge of the past, present, and new upcoming research is being conducted. Our global goals of zero carbon emission and performance driven sustainable design can be achieved. But there's a long way to go. We are very much thankful to you, sir, for sharing your valuable knowledge and time with us, for introducing us to the vast field of computational design. I am sure it will be immensely helpful for us, and we are encouraged to play our part in achieving our global goals. Thank you, sir.
Thank you. Thank you. I would like to thank all the Atelier team, and it was nice to see all the new students from MSU. I don't know like how many you know me, but it was good to see new faces. I So yeah, I would wish you all good luck, and I wish you all the success in your future. Thank you. Thank you for inviting me.
Thank you, sir.
Thank you, sir.